You also have to know the proof of the sum of a geometric series. To remind you, I've got a geometric series on the board, so that's the sum for n terms, denoted by Sn. Here are my n terms in the geometric series. And here's the formula to add them up, add up n terms. You get this in the formula booklet, but you have to know how to prove it, as I just said. So we're going to have a look at the proof now. Line 1 is to simply write out the series in expanded form. Line 2 is to multiply through that equation by r. So this becomes AR, this becomes AR squared, AR cubed, plus blah blah blah, and then right at the end we've got AR to the power n. And then the third line is quite a neat trick to cut out some of these terms. What we do is take the first line and subtract the second. So we're going to do this line, take away this line. On the left hand side we get that. So just this, take away this. On the right hand side, have a look at what happens. If we're doing the top, take away the bottom, you can probably see there are a lot of common terms on the top row and the bottom row, or the first row and the second row. So if you're doing the top, take away the bottom, these two terms cancel out. AR take away AR. Also, you'll have AR squared take away AR squared. Though I haven't written it, there's an AR cubed here, and you'll be subtracting this AR cubed here, and so on and so on, all the way up to AR to the n minus 1. We'll subtract AR to the n minus 1 here, which I haven't written. Which means if you do the top row, take away the bottom row, the only terms that don't cancel are this one here and this one here. So we'll have that, take away that. And it neatens up quite nicely, and you've probably got the algebra now to get from this to that. First of all, we'll factorise both sides. And then finally, we'll divide by 1 minus r. I'll just draw a small square to show that I've finished the proof.